So how many of you think measurement is easy? I mean, just take a tape measure, right? Yeah, but you can't make many decisions off of that. So this is what we're struggling with. What I'm going to do is bring you into my world and the problems that we're dealing with. And then talk about some of the ways that we've seen that have been successful. This is ongoing research. We're in the middle of doing a lot of expansion and transition and finding out what the real world challenges are and then trying to figure out how to make them fit in a way that we can make sense out of it. This is my world. And you'll notice that none of these lines connect. We have policies and guidance. We have mission users that want capabilities. We have a life cycle process for developing systems. We have a DevSecOps development process for creating software. And then we have a certification process. And what connects all of these pieces together? Documents thrown over the wall from one group to another is the most common way it's connected. Another way it's connected is with money. Follow the money and you will find out who's really doing what. And the third piece, contracts. And I am talking about the acquisition contracts now, not the other kind the fellow earlier was talking about. So just to give you a little bit more perspective, I would suggest to you that the reason this works right now and we get anything off the back end that functions is, thank God, we have heroes who will fight their way through the bureaucracy, the inertia and the current ways of making decisions to get things done so that we can get things fielded. But what do we get fielded that goes out in there to operations? An awful lot of uncertain capability. Now let's talk about why, because that's what we're trying to improve, essentially. We've got some capability that someone wants. So they apply money and they write a contract, a statement of work that goes to a vendor. Through a process that we call the acquisition process that goes through selection and then evaluation, and then the contract is signed and the vendor has the statement of work. But this is a very high-level description of what needs to get done. So the vendor, who's that second line down now, takes those initial requirements and translates them into a systems design. So we're putting a boundary around what we're going to build and what it's going to look like. And then those pieces are translated into hardware and software components that we then go through a rigorous process of hopefully testing and evaluating and then ultimately certifying. So we have to drop down to this bottom line and then fielding. If that sounds complicated, it is. And it's a cloud of a miracle happens between each one of those steps. And why is that? Some of it is because of the technology. We create systems designs in model-based engineering. Doors, Cameo, they throw tools around beautifully. Then we somehow translate that into story points that go into a DevSecOps pipeline for the software elements, and then design specs that go out to hardware creators. And then at some point we try and marry that when we test it. And if we're lucky, the hardware's ready. Most of the time it's not. So we have to write some software that simulates the hardware that we then run the software that's supposed to run on the hardware under and hope it matches that up, and then eventually we get to run it on the real hardware, but sometimes we don't even get that far until it's actually fielded. The policy and governance establishes the kinds of security controls that we need relative to the system. So these controls are all lovingly integrated into our system's design. Now, how do those controls translate into something for a DevSecOps pipeline? How do they translate into stories? Anybody know? Have you ever heard of misuse and abuse cases? Constraints? Those are the things that basically define what the software will be bounded by, which is ultimately what your controls are. Do you think we teach software engineers anything about misuse and abuse cases and constraints? So we have another gap. Now, aside from that, we're going through the DevSecOps pipeline, and we're creating and identifying vulnerabilities. And we've got our vulnerability database, we're managing that, and we're determining and fixing these things as fast as we can. You know, counting them and improving them and putting it all together. And then we know we've got some residual risk. And some of that, because they've compressed the schedule, may end up being so onerous that the security people are saying, you can't feel that. Well, where does that decision go? It goes up to the top, to the folks who are running the mission, to saying it can't be fielded. Well, how can that be right? Because we met our cost and schedule plan. Because that's all they see in terms of the documents that come up to them. How the contractor is doing based on their cost and schedule. So the disconnects are just amazing. And essentially, at this point, it becomes a political fight as to who's got the most clout to push it out in the field, and then the poor guys that are doing sustainment have to figure out how to deal with this if it doesn't run and you get the blue screen of death in the middle of everything. We had one pilot project for a program that fortunately did get canceled because it was a tank that the security system put a skiff on. And it took them 30 minutes to reboot it every time from a cold start, because that's the only way they could sync up all the 3 levels of classification. Now, can you imagine a tank moving around in the field and it takes you 30 minutes to get it restarted if it happens to stall? Not exactly the best logical thinking going, but how many developers really know where their components are going when they're writing them? Do you have a picture of the system so that you know logically and structurally what's going to happen? In many cases, no. You've got a little set of functionality and you're creating these pieces just to do that. And if you don't have the right constraints and the right understanding of what can go wrong and what you can't tolerate for going wrong, you really don't have the right specifications, but you don't even know it. So it's an interesting world to function in. And in many cases, what we're doing is we're going back up to the mission when things go wrong down here and starting to look at where did the decisions go wrong? What happened? I do a lot of forensics on that. And that also applies to supply chain risk management, because the decisions of which suppliers are going to be selected and how we're going to integrate them are made arbitrarily throughout this whole process. Systems engineers decide what languages are going to be used, and then they decide which language libraries are going to be used. The software designers are setting up the tool suites that are going to be operated and how they're going to be checking the gateways for requirements and meet that. But those don't necessarily match the user's requirements. And then You've got third-party software and services that many times are bought for the organization. They are not bought for the system. So you inherit all of this interface that may or may not match the risk tolerances that need to be there in terms of the requirements. Does anyone disagree with my picture? I mean, I'm open to other views, but this is what I've seen in my way of operating. And a lot of what we spend our time doing is translating among all these different groups, because everyone speaks a different language. They have a different set of goals. They have a different operating cycle. They have a different interface cycle. And the communications between all of these groups is done with documents. Well, if nobody looks at those documents, then they won't even know there's a problem. And many contracting processes for the requirements between your prime contractor and the government, especially, has a 45-day window of review. Otherwise, the government automatically accepts them. We're not even looking for the errors. So it's an interesting process to analyze and try and figure out how to measure. You got cost and schedule at the top. You got vulnerabilities at the bottom. You've got none of these groups talking to each other unless they have a risk management process that evaluates each level and ties them together. But few organizations have that in place. So what do they do from a security perspective? Let's start down at that side. You do the risk management framework, which is what is frequently applied in the government settings that we work in. And those are controls. And there's nothing wrong with the controls. They're applied to critical assets primarily. Those are the ones you're focused on. So what are you building for your critical assets? You're building a boundary around them to protect them. I think we've heard a few people talk about boundary problems throughout the last 2 days, but that's what we're relying on. And then for your outer system, you have your authentication and authorization boundaries. Who's looking at if that boundary gets breached to make sure that they don't get through your critical asset? Well, that depends on how the system was designed. Is there even a monitoring process that's looking for it? But we have examples, and this is out in industry, where nobody's looking at it. RSA's breach problem was a difficulty that the attacker got in, and no one was looking at those kinds of inputs. And then you have the outer enterprise. Many times your infrastructure and your connections for your users. I heard somebody mention single sign-on. Where do you think that lives? Out in the enterprise. But guess what? The system inherits it. But the risks, the way the system is looking at them, they are looking at them from an RMF perspective, and they're only looking internally. So what does that mean they're missing? Well, in many cases, a lot. So the threat perspective that we bring from a system user view in terms of what I care about is driven in many cases by policy and guidance, because they are not experts in threat modeling. They don't pretend to be. So these documents then drive what they're concerned about, and then that's what the security people monitor and present on. But we've already said that those should be translated into controls, which should be translated into misuse and abuse cases, and most developers don't know what to do with that. So we have gaps already beyond what we were talking about with vulnerabilities. And they're not even looking at these. This is outside of that zone until someone like me comes in and goes, what are you doing about supply chain? No, actually, I ask a first question. Who is managing your supply chain? And there are times when it takes them months to find out the answer to that question. And it's some lone little warm body sitting over in a desk in a far office who is handling hardware only. Why? Well, software doesn't wear out. So once it's tested, we know it works perfectly. So it has no reliability issues, so I'm not worried about it in terms of the issues of supply chain. I'm worried about counterfeits and all this other stuff. So we don't have enough intrinsic knowledge of the risk of software in the different lines that are all running to create capability for us to use technology to even begin to understand why we should be concerned. And then I bring up a few issues to educate the senior leadership. Like, you know, we've had a few supply chain problems, and the CrowdStrike attack a couple of weeks ago was not really an attack. It was just the way we've got such a interesting interface of complexity together that sometimes things happen. But you have a aura at the capability and mission level that is created by the vendor PowerPoint slides that show them how the process is going to work. And that is the expectation they go into when they want their fielded capability. And as long as the user interface matches that, they assume the rest of it is just fine, because they don't know enough to ask the right questions until someone like me walks in the door and starts digging a little bit below the contract. We do things like go in and look at the statement of work and find out where their security requirements are, and then match that to the documents that the vendor has been throwing back saying this is what we're doing. And then we start matching that to the designs that are in the databases and seeing where those pieces are and identifying the gaps and establishing the risks that those mean. So we go from, you know, an almost unpopulated risk database to one that is throbbing with problems. I'm not popular sometimes. But then this is not popular either, from what I can tell. So how did we get here? We got here because everyone wants capability. They want it quickly, like any consumer. They want it yesterday. And they want it cheap as possible, preferably free. So open source is, you know, very popular because it's this great fount of things that are already there, and they can't understand why it takes so long for someone when they're building something from scratch to create it to meet their specifications when the open source stuff is just there to use. It's a problem of matching expectations. And the people that control the money are the ones that have those expectations. So in many cases, the developers would like to do the right thing, but nobody will buy them the tools to do the scanning with it because nobody put that in as part of the cost of what was going to have to be done. And then I've already talked about the supply chain challenges. And the knowledge of what is abnormal behavior is nobody's responsibility to figure out. Everything is focused on what we lovingly refer to as the happy path. Does it work and essentially, does it go to end of job? And does it do all the glorious things they said it did in the slides? But does it address effective software assurance, which also means free from vulnerabilities? But when you talk about functions as intended, you also have to think about doesn't do what it's not supposed to do. But if nobody's looking for the not supposed to do, that represents a gaping risk. And we're seeing that coming through in spades, especially from the supply chain. So how do we start to measure this? What do we got? One of the things that programs already track most of the time are quality defects. And so one of the major research efforts that I led years ago was looking at these quality defects and saying, does that tell us anything about the vulnerabilities? And essentially, you can estimate that from your defect level, 5% of that will be vulnerabilities. And that's held pretty true based on the mapping that we've done and continue to monitor. So what does that mean? Well, if you have best-in-class code, you've got less than 600 defects per million lines of code. So you take 5% of that, and that's not too big a number. Maybe the risk is what I can live with. But most of these systems have upwards of 35 to 50 to 75 million lines of code. How many of you believe all of that is best in class? Any takers on that? The F-35 has 35 million lines of code in it. Best in class? Average. Average, 6,000 defects per million lines of code times 5%. Now, how many of you believe boundary controls are going to protect you when you've got that many defects sitting at the enterprise level, and then at the system level, and then at the critical? Maybe you don't have that many of the critical assets, because that's probably where you're really focused on making it closer to best in class. But the rest of it, starting to get to serious numbers. How many projects do you think track this, the 5%? Very few. Because no one is tracking vulnerabilities at the system level. They're tracking quality defects. So it's a metric nobody's looking at. But it's one they should be tracking just like they're tracking defects, because you can project it just as closely. What should projects be doing? Not just, I'm running code guidelines, that's what, halfway through? I should be all the way back up here. My requirements should have risk scenarios. That doesn't do what it's not supposed to do should be defined somewhere. We do have them for safety. The plane shall not fall out of the air. It's not complicated, but it does become part of the requirements. How many of you have ever heard of anybody talk about not letting anyone in through the boundaries, so that you've got monitoring and managing going on in that soft, squishy space where all the insiders live? We don't have that yet. We don't even have that thinking yet. I did mention abuse cases. We already know that we've got problems with that. And we've tried to do threat modeling. We find many organizations do it very well at the system level. That means they're verifying, do they have the right controls in place? But they're not looking at the software level, because nobody is assigned to manage the risks at the software level. And then those carry all the way through. I forgot to point out one thing. Look at where we got, most of our flaws are introduced at the design. So that means most of our vulnerabilities actually come in at the design level. And I think I've just explained to you that no one's looking for vulnerabilities at the design level. So those carry straight on out to the operational field. One of the activities that we put in place relative to the supply chain, because that we've seen is a major gaping hole, is looking at what kind of practices should be in place for supply chain. And we have identified, based on going through all the guidelines and all different contract requirements and all the different things that should be there, essentially 6 key areas that play as part of the system and acquisition lifecycle into relationships with the supply chain. And so we were able to identify essentially 51 goals and 334 practices that should be scattered throughout that. Your one lone little person managing hardware supply chain needs help. The link is there, it's published, this is all public for you. And I'll go a little bit more in detail of why we organized it the way we did. But first I want to talk about what should be measured. From a perspective of we want a system with effective assurance. What should be measured is predictions coming through the first part of the life cycle, and then verification out to the back. There is a technique that we can start to identify measurements, and this has nothing to do with just software assurance. It's just any kind of measurement that is tied with, it's called goal, question, indicator measures. And it is a very detailed process, and the links are there for you to put it together. And we have taken this into programs to actually help them figure out, how do we measure this stuff besides just looking at cost and schedule? What is it we care about, and then how do we measure it? As some examples, this is one of the goals within the acquisition security framework, and we've outlined the different activities as questions. So you can start with the questions that you care about, and then from there start to drive it into what are the measures that I can use. One of the other techniques that we've put in place is to look at what are the measures that programs are already doing, and can we leverage something that may be already there. To leverage it, it's got to be in our contract, because the vendor's not going to give it to us unless we specify it. So we can't just assume that we can just pick one of these measures and waltz around and just pull it out. You've got to go back to the contract and make sure it flows through to get the data. So all of these are interconnected through those loving documents. But once you do figure out what is it you need, that's how you go after it. We have a whole series of these for each different part of the life cycle that we put together with our research that we did with 3 major vendors, 3 major acquisition projects, rather. And that is a published document, and the link is in the references I've included. If we just pick this one with supply chain, which is another one of the links, and this should include considerations for open source, we have another activity underway where we are looking at what is it in the open source world that we can measure. And we've come up with a process that says, okay, let's review the available data. We've identified, as a starting point, a series of useful criteria. And then across from that, looking at it relative to our project, the product, the protections we want, and the policies that need to be in place for us to have that from the vendor. Essentially, we're creating a way to measure what's happening from open source and create red flags based on these elements that would raise concerns that we then need to go out and verify for that particular open source, that how we're going to address our concerns. That may mean we have to partner with that open source, or we have to select another open source because that one's unacceptable. Now, I'm getting to the end of my time, but I do want to let you know that we have piloted this with Unified Platform, And the work that has been done, and it has been automated, is going to be briefed by Scott Hissam is the coordinator on that one. It's going to be briefed at the SOSS Fusion 2024, which is going to be October 22-23 in Atlanta. That's being held by, coordinated by the Linux Foundation. So you might want to keep an eye on that to get more details. As I told you, this is research in process. And that's how far we've gotten. And so I'm happy to entertain questions. Yeah.
I was just trying to ask a quick question concerning how this relates. It seems like this is kissing cousins to vendor risk management in terms of how it's so close to it.
But what we're leveraging is what's actually, we know, being done instead of some general process that we're trying to enforce.
Okay.
Just wanted to ask, what's the difference between goal-driven measurement and, I know in the industry, key performance indicators is regularly used. Is there a relation between these?
That I don't know.
Okay.
I'm not the GQIM expert. We just always make sure we have one of those on our team because it's been very useful. And it's well documented. And
just one more question was, when you mentioned about 70% of vulnerabilities are stem from the very beginning of the developments and requirements stages, right? Even before software development, that is. So is a solution to that?
That's not the vulnerabilities. That's the defects.
The
that come
defects.
in at that level. So that's quality evaluations that are being applied.
Okay, thank you.
And which is deviations from requirements.
So is this isn't doing like work like? I'm trying to be very careful with my words in here, so forgive me if I'm being like flippant. But isn't doing like workshops or trying to make things early on during this process, going back to waterfall where you're trying to make things.
It's about 15 years worth of data collection of what's actually happened in programs, and doing backtracking and forensics on where did those get introduced, that the data was assembled from that built those statistics.
It's more, you're observing these things. You're not just trying to like enforcing. It's just like,
now,
this is
I'm
what's
not the quality expert. So the groups that's doing quality, yes. I'm observing the, once they define something as a quality problem, then how many of those translate into vulnerabilities? Those are the pieces we've evaluated.
Okay.
I have been working in the federal marketplace for software development, and I find that there has been significant work done in managing the supply chain, and most recent being the CMMC, that's supposed to manage the supply chain from the security point of view.
It's a good idea, but it's not in practice yet.
Will that, if that is practice, is not really required?
So it's not part of, it will be useful data once it gets in practice, but in order for something like CMC to get in practice, it has to be first put on contract. And the programs would have to completely restructure their contracts to then mandate that from the vendors. And it's not on the contracts we're seeing right now.
It is 6 months from now.
So it might be something that's coming in the future that would improve things.
Very much part of it, yeah, very much part of it. But much of the errors are introduced in the flawed design, which CI has already designed a very working model based of CMI and model-based system design. Is that adequately serving that? And in most cases, there is a risk management plan developed. Is that not adequate, or just the implementation that is not right? Where is the flaw?
What we're seeing in the systems design is that may be robust. Yeah, okay. Did you want to go back?
I just want a microphone, sorry.
Okay.
So CMMC is really for vendors and contractors for their enterprise networks to certify that they can handle CUI data, right? What Carol's talking about is actual weapon systems. I'm building an aircraft, I'm building a ship, I'm building a rocket, a missile, medical device, right? It's just, I know I just list off a bunch of DoD type of stuff, but it's just as true for, medical device, anywhere where it's critical, life type of stuff, right? Those things are not being subjected to CMMC. CMMC is really your enterprise infrastructure. So what Carol's talking about, no, it's not adequate because she's talking about the risk in the cyber attacks associated with the products and the services that you're selling and servicing for end users.
It may help in that
not your
enterprise.
Windows email server system.
But
that's CMMC.
But I think government is trying to force this implementation on vendors so that they are prepared to handle the situation. Otherwise, it will be meaningless to ask them to implement it, which is not producing.
So the problem is the people who decide what applications you're allowed to put on your network from a CMMC perspective are not necessarily the same people who are evaluating your third-party open source software that you're putting on your weapon system or that product that you're selling via your contract.
Yeah, but I mean, I don't know who is what evaluating what, but I think all contractors' intent is to provide what the government expects in writing and what ideally should be done. We work with we try to read the government mind and try to do the best we could. So there is a lot of work that we do that is not so officially prescribed.
Right.
Because
So
we want to be in the business, we do go above and beyond. So I think there is much more being done than is talked about it, and much more being done without specifying so much. But still, there is not much way to.
But right now, all of that is out in the policy and governance
Yeah.
wing. And you'll notice that it's not connected directly to any of these layers.
One more I want to say that I think there is coming from a smaller and larger system, there is a good amount of work being done by government trusting and vendor trusting government people to manage the work. Much of the work is being done because there is no amount of work you can do upfront to trace all the costs associated with the product. So that is how the system is currently done.
It's not a technology problem. It's a management problem.
Yeah, but I think that's what's being done. Now
we know how to do these things.
Yeah,
we know how to measure.
Yeah.
We know how to what tasks need to be done. We know how the pieces need to work.
Yeah.
But we have an operating environment that doesn't put them together right now.
I think it's just a matter of who is doing it. I think we are building fail-safe software, building planes, building all kinds of sophisticated that rarely fails. So we are doing quality work. Depends upon.
That's probably true of who is doing it, but we're not training the people that are doing these roles to address the issues.
So I mean, it's not a chaotic situation. The government is not chaotic.
There's a whole raft of problems related to it, but
yeah.
this is the result we've got.
Yeah, thank you. So
Sure.
I just, thank you. This is, really informative. I'm glad to know there's someone out there putting this level of thought into the problem. My question comes from working with government software license managers, asset managers, supply chain risk management folks. Is there any analysis around 50-some goals, 360-some best practices? What is that? I see a dollar sign and a lot of zeros attached to that. I don't think it's from, I'm sure part of the problem is training and education, but it's also resources. What does that cost? And then the next question would be, how can an organization kind of think about prioritizing all those goals and all those things that they need to do? Any thoughts on that, or how you've seen maybe units, organizations do that well?
Well, I will point out to you that we just published this in 2023, so we haven't had a lot of piloting experience yet. Where we see it in the narrow spaces that we brought it into is that they recognize where they're seeing the problems, and from a leadership standpoint, it gives them the questions to ask. So at least from a starting point, they know how to begin to scratch against the problem space. How much it's going to ultimately cost, we don't know. We haven't been working with it long enough to be able to give you any decent numbers.
Gotcha. Thank you.
Sure. Thank you. Thank you.